Okay, in this video I show you my spybug, and this is the I have two PCB. One is this and the other is this. This PCB is possible to make one PCB with soldering into face of PCB. It's possible, but it is more difficult, and this is a prototype, and I prefer make one PCB, tested the RF part, and when it's done, I make this PCB preamplifier audio with the microphone. I tested, and when two PCBs work, I soldered two PCB together, and this is the RF part. This is it's not my idea. It's not my it's my schematic, but it's not my idea. I put a link in description of video in YouTube when the guy use this chip for transmit in FM band. This chip is Max 1472. Normally is used for ASK, but with simple tricks it's possible to use an FM modulation. The original guy I made, I use this chip, and I use these tricks of a varicap for change frequency of crystal. It made very simple circuits. You don't have much impedance. You don't have a filter output. This schematic for the RF part. For this schematic, I'm not. It's not my schematic, but I put the datasheet note application and copy and paste. This is these outputs and value of components. It's possible to make 433 megahertz, 350 megahertz, and the other frequency, but you need to change much impedance and the filter output. This is for the RF part, and I made a PCB. I make this PCB with EasyID, and I guess this is all for the RF part. Now, this is the preamplifier of the board of the spybug. This is my schematic. I learn. I try different version, but this is very well. I use an electret microphone. This microphone it's high sensibility. For the capacitor, I use the NP0 or COG. This is the tantalum, and for the first stage I use this little chip here. Is a Max 9812. It's I have a bias for the microphone. This is a chip I use for the audio amplifier. And after this, I have a class A amplifier with this transistor. And after this, I have an op amp for the last amplification. I have a gain of 1750 plus or minus the total gain. And yes, it's all. I made two of this with the difference. I have two difference. I made this here. You're watching, yeah. I made this. What is the difference? The difference of these, the preamplifier, it's same. The RF transmitter is the same. The RF power of max 1470 is 10 dBm. It's a very it's good power. I try the distance with this little board and arrive plus or minus 200 meter. But this antenna is not optimized. I just use a calculator online and take a piece of wire, cut and nothing else. It's possible adjust the antenna very well with a good SWR, and it's possible 300 meter, 400 meter, and for the receiver I use a Boifang with the antenna stock, but yes, I tested 200 meter, but it's much more. 10 milliwatts with a good antenna is much more. But the difference, okay, this is the same, but I have here a regulator for because I use a LiPo battery. This is a mini regulator, 3.3 volt linear regulator. This is very quiet, is important, and when the resistor is a metal film resistor, is quite. This op amp is very quiet. It's very important to use good components because the noise is everywhere. The resistor is noise, the microphone have noise, transistor noise, amplifier noise, capacitor is a noise, the regulator have a noise. All these components have a noise because it is important take the right components. But the difference is, okay, the regulator, and the last difference is here. It's impossible to see, but after you put the photo here in the back of the PCB, I have a little circuit, and this circuit is simple. When I have a sound, it's enable the RF output, and if not have a sound, disable the RF output. This is important because 10 milliwatts, 3.3 volt is a 60 milliampere. 60 milliampere. It's much, and this is to save a life of battery. And this is the two difference of this here and this here. Now I try a test. I use this. It's powered by 2 AA battery, normal battery, and this is normal battery, and this spybug. Okay, I try. Okay. Just one moment. First, the video test of the test. I watch you the RF trigger circuits. Okay. Now I have a signal. Okay. I stop talk. The signal disappears, and now, okay, is now have a signal. Is the last test. I don't speak. Okay, now speak, and now speak, and yes. Okay, the signal is go. No, the signal it's here. Okay, and the microphone is here. Okay, and now test the voice, the sound quality. Okay. Okay, this is a test. The microphone it's here, and here a tablet. The microphone, and here the distance is 2 meters, plus or minus. Okay, now 300 millivolts, even more. The video. And this okay. On this distance, this is quite nice. And this is the sound. And, let's connect AC coupling on the output. Yes. Now close the door. Okay. I take my Wi-Fi. And this is the audio. The output is on DC. We get our 0 here, and I can go down. This is narrowband. So this is a good result. This is wideband. Let's connect this to the sound card and test it. So what we need now is to add this phone jack here. I got from an old camera, and have to connect it also. It's not very clear, but it's good. We have to connect this to our minus to get a common ground here, and we have to connect, I guess it was one to our output, and we can connect the probe here and get the probe to the sound card, phone jack, and the so I have Audacity over here, which is an open source audio recorder, and my electret microphone over here. Okay, this is the sound. Okay, the test is good. The microphone and the spybug is very sensitive, and for this video it's all. And now I put the photo of the PCB, and this is it. thank you for watch this video, and see you next time. Thank you. Bye bye.